Hey everyone, welcome back to another weather video. Today we'll be taking a look at our first winter outlook of the year. Now I waited a little bit longer than last year because I learned from my mistakes. You can't forecast a winter outlook in July, June. You're just pretty stupid and you're throwing up random ideas at that point. I wouldn't say random, but I'd say more of guesses in the dark. You really don't know what's going to happen. But now we're starting to see clues across the globe, whether it be across the Pacific, and even Northern Pacific, as we have two potential big factors forming for our 2025-2026 winter season. Now, as we get a close-up on our sea surface temperatures, there is two parts of the Pacific that I want you to look at. The Northern Pacific, from America all the way to Asia, and right off the coast of South America. Winds from South America have been pushing the water west, causing upwelling to occur. What happens during upwelling? Cooler waters at the bottom of the ocean get upwelled and brought up to the surface because it's constantly moving and mixing with the warmer temperatures, causing your cooler than normal sea surface temperature anomalies. And what do we call that usually? We call that a La Nina. A La Nina usually causes a hyperactive hurricane season. But as we all know, we haven't had any significant hurricanes besides one. And that went out to sea and caused all this cool water off the eastern part of the country. Now, since that has happened, and if that stays throughout winter, you will be in a great position, coastal snow lovers, if anywhere in between, let's say, Southern Virginia, most northern parts of North Carolina, to Connecticut and Nantucket. Anywhere in between there, if that cold pocket of water stays throughout winter and you have a nor'easter, you will have a better chance of staying all snow instead of switching over to maybe rain or even a mix of rain and snow. If that stays, of course. Now, up to the Northern Pacific. Notice you have two big pockets of warmer than average temperatures. Not saying this area is well above average, but I'm saying there is two areas to focus on. Let me just clear this up real quick. So you have the Gulf of Alaska, western parts of Canada, and the western part of the US. And then you also have coastal China, Japan, Russia, and Korea's. As I was saying before, if you get, let's say, this well above average temperatures pocket in an area of body of ocean, right? Storms will want to form. Storms love to produce energy, especially when you have all this potential energy, the warm water in the region. What happens when storms start to build energy? A high pressure eventually starts to get formed. There is not a lot of storms. Let's take a hurricane, for example. If the track's over colder waters, like if a hurricane were to track over this, obviously, once it reaches this far north in latitude, it's going to start to diminish in strength anyways. But I'm just saying, for example, if it were to track over a body of cold ocean water temps like that, it would weaken. But notice how usually when you get your hurricanes to track into the Caribbean and Gulf of Mexico, you notice how they tend to explode in strength. We have a term called rapid intensification, where these storms get into a nice favorable environment and start to produce at a quick speed. That is exactly why if you get a warm body of ocean temperatures like this, high pressure will eventually start to form. And eventually, if you get a high pressure that forms in the Alaska Canadian region, that is called a negative EPO, Eastern Pacific Oscillation. That is a block pretty much that is up here. And if you also get a positive PNA, which is also possible to form more often since you have this body of warm ocean, you get a ridge out west. And you know what must go up must come down. So you get a trough out in the eastern US. Now, let's say, usually if a La Nina were to stay through a whole winter, you would also have a high pressure out here. But notice, as of right now, where I just circled with the H, it's a mix of higher and lower than normal sea surface temperatures. It's nothing crazy, right? Yeah, it's maybe a half a degree to a degree above average, and you could say half a degree or full degree below average. Nothing like the Eastern Pacific where it's on fire, pretty much, you could say. Whereas you got 3.6 to 2, maybe even pockets of 4 to 5 degrees above average. Not as much as the Western Pacific, but still pretty good. Pretty good amount, right? I expect there will be times where you could get a southeastern ridge that tries to form. I don't think it would get too strong because there's nothing crazy to force it to go west, retrograde west into the US, get a eastern Atlantic fire hose. But like I said, if you get constant ridging out here, you will get constant troughing out east. Now, obviously, there will be times where the La Nina takes over and the MGL goes into a phase where it's not favorable, and you would probably get troughing out in the central part of the country or even western part of the country, and you warm up for a little bit on the eastern part of the U.S. But I love, as a snow lover that lives in the Northeast, I love what I see right here. I also love what I see right here too. There will be other factors that I will be talking about that will also determine our winter, such as our AO, Arctic Oscillation, NAO, North Atlantic Oscillation, and maybe you could throw in the IDO that's pretty much over here, and MJO, which right over here. But of course, we'll get more into. Now, what we are looking at right now is 10 millibar height anomalies in the Arctic region. As of right now, clearly, let me just move this down a little bit more for you guys. You don't see anything, right? It's just a bunch of red, light red, orange across the whole country. I wouldn't even say country, I would say across the whole northern hemisphere, right? This will be eventually our polar vortex, where normally it sits right here and spins round and round and round and round. If you get a strong polar vortex, you will get constantly spinning like this, just like a normal low pressure, counterclockwise, across the northern Arctic and into Siberia. Now, let's say if you get a weak polar vortex, normally it goes into an oval-like shape. Notice how the winds start to flow over North America, more deeper into Siberia. The more you get this thing to stretch, the more Arctic air gets displaced. And now, if you get a polar vortex that splits, oh man, that you are really set for a great time if you're a snow lover. You get warming, blocking in the northern hemisphere, right? You get one lobe of the polar vortex to sit over Siberia, and you get another that sits pretty much almost in Hudson Bay. You are going to get a severe, and I mean severe, Arctic outbreak. That is when our most cold times during winter come, during a polar vortex split. Now, if this happens in late December, it takes, any time during winter, it takes 3 to 4 weeks to translate down to the surface. Once again, you are 10 millibars up into the atmosphere right here. Now, once again, if you wait 3 to 4 weeks, and it happens in late December, you get extreme cold that happen during the heart of winter. And especially if you have snowpack on the ground, let's say in southeastern Canada, and even parts of the eastern part of the US, you are going to be seeing teens, single digits, and in most interior parts of the country, negative temperatures. Now, obviously, once again, sorry to backtrack, there's nothing there, right? But as we go on across time, you could see these lines more start to form, and then eventually, you have your polar vortex. It is still extremely weak, because the polar vortex just started to begin again. Sorry about that. I don't know why highlighter came up. It's finally starting to build up again. You see, you have your rings start to form. And if we compare that to when it just started at the beginning, as we sit right now, you can see it's nothing even remotely close to that. So this is a great sign to see that our polar vortex is finally coming back to life. Now, once again, if this wants to... Sorry about that. I don't even know what I just said. If you want to have a great winter, you want this thing to be tacked by warm temperatures either over here, and either displace this thing south, or just straight up split it in half in general. Now, once we get closer to winter, when this thing starts to build up even more, you will start to see how important this thing is to our weather. When it splits, usually, not all the time, but usually, let me just clean everything up for you guys real quick. Usually, if it splits, you get big time blocking up in here. Our AO and NAO go negative. When they are negative, you get high pressure over Greenland, high pressure over the Arctic Ocean. Now, if you get it also could translate to a negative EPO too. So, if that happens, you have nowhere, and I mean nowhere, for the cold to be up here. So it gets translated and disputed south and northward. I said it backwards, but you get the point. South, here, right? Both south towards the US, Canada, and Siberia. Obviously, you have nowhere for the cold to go, and this is when almost, I would say, 80% of the country starts to go below average, and then I would say about 40% of the country goes well below average. Obviously, it would depend if you have a positive PNA. If you have a positive PNA, the more Arctic air would be distributed out of here than west. But if it's negative PNA, where you just have, I don't know, let's say blocking out here, blocking over here, more of the cold would be disputed over here. And it also depends, once again, the southeast ridge, if it wants to pop up or not. That is a very important factor throughout this year. But I do tend to believe the La Nina will turn into La Nada, nothing. And I would say the La Nina wouldn't have much of an impact on our weather going from December to January to February. The deeper we get into winter, the less of a factor I believe the La Nina will be. Now I just want to show you real quick an animation of our ice throughout the past 60 days. Notice you can see it starts to grow out a little bit. Then the last couple days of August into September, you can really see that ice start to melt away. Now you may be thinking, wow, that's really bad for winter, right? Because our ice and snow is starting to melt as we get closer to winter. Not at all. And actually, matter of fact, I'll show the snow graph first. We are about to be, let me just get this graph up again. We are about to be where our snow finally starts to regrow and take off. Usually by October and November is when you see rapid growth of our snow in the northern hemisphere, especially of course into December, January, when it is freezing up there, absolutely freezing. But anywhere pretty much from July to, I'd say, September 15th, maybe a little bit later, is where our ice just is not there almost. It is there, but very thin. That's completely normal. As you can see, let me just scroll down a little bit here. Take away everything I did. If we scroll down, you can see it's pretty normal. Our minimum for the past, let's say, 7 years, this is when the minimum ice has been. So pretty much anywhere from early August to late August has been our minimum ice. And if we go over to, excuse me, this is snow, not ice. This is where our minimum snow has been. If we go to the ice trend graph, we can see that's pretty much the same thing here, anywhere from September to pretty much, I'd say, October 15th, once again. That's where our lowest pocket of ice begins to, say, melt. Our lowest areas gone, and our bigger pocket of areas just barely hold on. And then eventually after that, it starts to grow rapidly up until, let's say, March and April. Especially into April, it starts to melt a little bit. But yeah, this is completely normal, nothing out of the ordinary. And you can see here, our minimum sea ice, according to this, yeah, alright, that's a little bit weird. But it says September 7th, even though it's not out to September 7th yet. This is our minimum so far. I'm uploading this on September 8th. Obviously, it's not updated every day, but I would expect a range from mid-September to early October, our minimum ice would be. So yeah, this is completely normal, happens every single year. Finally, I just want to show you where our important areas to look out for this year during winter are, and if someone says these terms, you'll know what they are in the future. First, this is our Enzo region right down here. there'll be a La Nada where the temperatures are either from right here, either way from 0.5 to 0.5 in either direction. Sorry for the terrible line. But as you can see right now, since August 11th, it's been below this line. So technically, we've been in a La Nina for a month. It needs to be 3 months straight of constant higher, let's turn for it, higher than negative 0.5 degrees water temperatures out there throughout the whole region. And if it goes back up here, we're back in a La Nada. So I'm almost positive we would get out of a La Nina conditions if this were to stick around December, which is very good news for the pretty much anywhere across the United States, because La Nada, the whole country is cold throughout that time. And La Nina, usually the western part of America is colder than average. So if we go back here to our map, sorry, that's our ice. But if we go back to here, right, this is a very important factor to look out for. I'd say this is the most important factor to look at, and this is the second. If you hear the terms EPO and PNA, EPO is more up here and PNA is more down over here. If you're a snow lover in the eastern part of the US, you would want the EPO to be negative, that's a block up here, and the PNA to be positive, that's a block over here. And if you're a western snow lover, you would want to root for a positive EPO and a negative PNA, which is pretty much the opposite, troughing out here and troughing out here. Either way, I think you'll eventually go back and forth with a negative and positive EPO and PNA due to our potential La Nina or La Nada. We'll have to come closer to December and January to determine that. And this is our third most important thing right here. Our AO, Arctic Oscillation, when negative, distributes colder temperatures all the way down into the eastern part of the US and central. And the negative NAO, Northern Atlantic Oscillation, also does the same thing. Just when negative, it's a block. Also, when it's negative, it's a block. And when these are both positive, you usually have a strong polar vortex that just spins round and round and round and round, keeps the cold air locked up. Lastly, this is kinda important. If you have, let's say, a semi-strong southeast ridge and it clashes with a cold front, so let me draw that more better for you guys. Usually, if you have these two clashing right on the same boundary, right, you have a low pressure system that forms, and usually you could get pretty big storms out of that. So not all the time when you have a southeast ridge, it's going to be warm. There's a southeast ridge going on. It's going to be warm across the whole eastern part of the U.S. We're going to go up to 60 degrees. That doesn't happen all the time. If you get a spot where this thing semi-strong and it sets a boundary right over here, and then you get a nice cold trough out here, if you get a strong enough system, that could drag all the cold air you need to the coast, and that's when you get a big time storms. When the two boundaries clash and there's a lot of potential energy off the coast, eventually forms a storm, it goes boom, right off into the eastern part of the US. So yeah, it's a decently big factor, but it's not the end of the world if you have that going on. Thank you guys so much for watching this winter update. I will probably constantly, I wouldn't say almost every week, I would say every other week, I'd come out with another weather video for the winter. I'll be talking about more of the, let's say, Atlantic hurricane season going on now, and potentially if we get any other big storms across the country that comes off the coast and into the southwest, because they're dealing with a little bit of a drought over there. If anything comes up like that, I will be the first one to let you guys know. And thank you so much for watching. I hope you all have a wonderful day and week.